In this lecture, we're going to look at a very important package called NumPy, which is heavily used in scientific computations. So if you want to get into data science and machine learning, this is one of the packages you'll be using quite often. There are also several other packages that are built on top of this package. So it's a very comprehensive topic and it really requires its own course. But in this lecture, I'm going to give you a very sweet introduction to NumPy so you know what it is and what you can do with it. So here on the terminal, let's do pipenv install numpy. So NumPy enriches Python by bringing super fast multi-dimensional arrays that take less memory than the built-in lists in Python. So anytime you want to work with large multi-dimensional arrays, NumPy is your best friend. So let's import it on the top. Import NumPy. We can optionally give it an alias using the ask keyword. So call it np, and now we can access this module with np. This makes our code shorter because in a real application, you're going to use this package a lot. So we don't want to type numpy.numpy.numpy. Okay? Now, here we have this array function for creating an array. We can pass a normal list here, and this will return a NumPy array. Let's have a look. So print array. So here's our array, but this is actually a NumPy array. So if we print the type of this array, you can see it's an instance of n-dimensional array class in NumPy. Now here we can create a multi-dimensional array like this. So we have one list. In this list, each item is a list. Here's the first item. It's a list of 3 items. And here is the second list with 3 more items. So now we have a 2-dimensional array, which is called a matrix in math. Let's print this on the terminal. This is what we get. So we have a matrix with 2 rows and 3 columns. Now, this array object has an attribute called shape. So let's print array.shape and run the program. There you go. So as you see, this returns a tuple that specifies the number of items in each dimension. So here we have a matrix with 2 rows and 3 columns, and that's why we get a tuple with 2 and 3. Now, in NumPy, we have a bunch of helper methods for creating arrays and initializing them with zeros, ones, specific numbers, or random values. Let me show you. So np.zeros, this will create an array and initialize it with zeros. Now, the first argument to this method is a tuple that represents the shape of this array. So here we pass a tuple, let's say 3 and 4. Now we get an array and print it on the terminal. So we get a matrix of 3 rows and 4 columns, and each element is initialized to 0. Now, by default, all these numbers are floating point numbers. That's why we have this decimal point here. If you want to change the data type, you can pass a second argument here that is dtype. So dtype, we set this to, let's say, integer. Run the program again. So now all our numbers are integers. Now we have another method called ones, and we use that if you want to initialize this array with ones. Let's take a look. Here it is. We can also fill this array with a specific number. So we call the full method, and as the second argument, we pass the number we want to fill this array with. Let's say 5. And here's the result. So pretty cool, right? We also have a method for creating an array with random values. So we go to the random module. In this module, we have this random function. So we just pass the shape of this array, and this will create a 3x4 array, and every item is a random number. Now, if you want to do this in pure Python without NumPy, our code is definitely longer than this. It's going to be 2-3 lines of code. So NumPy makes a lot of trivial things really, really easy. So now we have a 3x4 array. We can access individual elements using an index. So here we have our array. Let's get the element at the first row and the first column. So print. So here's our array. And as you can see, the item at the first row and the first column is this number, which is printed here. Now, in contrast, if this array was a multi-dimensional list in Python, our code would end up looking like this. Array of 0 and 0. So we would have extra square brackets, and this would make our code a little bit noisy. Now, let me show you something really powerful. I'm going to print an expression like this, array greater than 0.2. Now let me comment out what we have on line 8. We don't need it anymore. Let's run the program. See what we get here. Here's our original array. And below that, we have an array of Boolean values. Each element determines if the corresponding element in the original array was greater than 0.2. Extremely powerful. If you want to do this in pure Python, we would have to write a lot more code than this simple expression. So NumPy arrays support various kinds of mathematical operations. We also have Boolean indexing, again, extremely powerful. So we print array of, now instead of using a numeric index, we use a Boolean expression. So let's say array is greater than 0.2. Let's run the program and see what happens. So this will return a new array with only the values that are greater than 0.2. We also have a bunch of functions for performing computations on arrays. Let me show you a few examples. So let's print numpy.sum, and we pass our array. This returns the sum of all items in this array. So here's the result. That's pretty cool. We also have floor, and this returns a new array with the exact same dimension and computes the floor of each item here. Similar to floor, we have ceil to get the ceiling of each number, or round. Let's run this. So when we round these numbers, we get an array of zeros and ones. Pretty cool. And one last thing before we finish this lecture. We can also perform arithmetic operations between arrays and numbers. Let me show you. So I'm going to delete all this code. Let's say we have one array here, np.array with 1, 2, 3. We have another array here. Now we can print first plus second. Let's run it. So here's the result. All the arithmetic operators that you're familiar with, like multiplication, division, subtraction, all these are supported by NumPy arrays. We can also add a number to our first array. Let's see what happens. So this creates a new array and adds 2 to each item in the original array. Now here's a real-world example of using this operation. Let's say we have an array of dimensions in inch, and we want to convert it to centimeters. So dimensions underline inch, we set it to numpy.array and pass 1, 2, 3 here. Now to convert these values to centimeter, we can write code like this. So dimensions underline centimeter equals dimensions underline inch multiplied by 2.54. Let's print the result. So there you go. Again, pretty easy. If you want to do this in pure Python without the use of NumPy, our code would be longer. Let me show you. So as comparison, we create dimensions inch and set it to a regular list in Python. Now we need a list comprehension to transform this array into a different array. So here's the syntax for list comprehension, item for item in list. In this case, our list is dimensions inch. Let's call each item x. Now we need to get x and multiply it by 2.54. And with this, we get dimensions underline centimeter. So this is the implementation in pure Python. And here's the implementation in NumPy. So NumPy provides multi-dimensional arrays that are super fast and take less memory. Plus, they support various kinds of mathematical operations that regular Python lists don't. So it's the core library for scientific computation.